Hi everyone, I hope you guys are doing really well. So I'm back with GATE-2002 solutions. Also, I would like to discuss one thing with you all that as we know that the format of the question paper has been changed now. Earlier there were some subjective questions also. So I have made the video of multiple choice questions, not the subjective ones. If you guys want me to do those also, I'll make part 2 of this video, and the link of the question paper is in the description box below as always, and let's start.
The inverse of the matrix is, so inverse is nothing but 1 upon determinant of A multiplied by adjoint of A. We can easily find out the determinant of A, which is 0.1, and adjoint of A is nothing but the matrix of all the minors, which is minor of A11 is zero point 0.5, minor of A12 will be 0, and similarly others also. So A inverse is 1 upon 0.1 multiplied by adjoint of A, which is this matrix. So we'll get to know that option C is correct. Next question. Which of the following conditions are satisfied at the critical point by PVT relation of real fluid? So the correct option is del 2P by del V square at constant temperature is equals to del P by del V at constant temperature is equals to 0. So this is the condition for real fluids. Which of the following holds for any non-zero vector A? So it's a property that the divergence of curl of A is 0, which is option C. Next, with the increasing flow rate, the hydraulic efficiency of a centrifugal pump. Okay, so this is the curve between efficiency and flow rate. So as you can see that it is increasing first, and at this particular point, which is best efficiency point, it will start decreasing. So the correct option is first it will increase, then it will decrease. Next, for flow past a flat plate, if x is the distance along the plate in the direction of flow, the boundary layer thickness is proportional to. So we know that boundary layer thickness is proportional to delta x, which is option A. Moving on to question number 7. For turbulent flow of incompressible fluid through a pipe, the flow rate is proportional to delta P to the power n. We have to find out the value of this exponent. So we know that delta P is 2FL rho V square by D, where F is the friction factor, L is the length, rho density, V is velocity. Also, flow rate is area into velocity. So we can write Q by A in place of V, and if we rearrange a bit, we will find out that Q is directly proportional to delta P to the power 1 by 2. So 1 by 2 is less than 1, therefore option C is correct. Eighth question. For an ideal PFR, the value of Peclet number is, we know that Peclet number is the ratio of advective transport rate to the mass diffusion rate. So in ideal PFR, D is equals to 0. Therefore, Peclet number will be infinite. Next question. The extent of reaction is different for different reactants and products, correct. Dimensionless, correct. The dependent on stoichiometric coefficients, this is also correct. So the correct option is all of the above. Next question. An exothermic reaction takes place in an adiabatic reactor. So the product temperature will always be greater than the reactor feed temperature. Therefore, option B is correct. In 11th question, methane is mixed with stoichiometric proportion of oxygen and completely combusted. The number of additional specifications required to determine the product flow rate and composition is. So this is the reaction scheme. We know the mole ratios, and for finding out the product flow rate, all we require is feed flow rate. So additional specification would be 1. Moving on to question number 12. If the baffle spacing in shell and tube heat exchanger increases, then the Reynolds number of the shell side fluid. So if the baffle spacing increases, the velocity will decrease, and Reynolds number and velocities are interrelated because Reynolds number is rho v d by mu, and if the velocity will decreases, Reynolds number will also decrease. Therefore, option D is correct. Next, the total investment in a project is 10 lakhs and the annual profit is 1.5 lakhs. So if the project life is 10 years, the simple rate of return on investment. Rate of return on investment is given by this formula. We are multiplying the life of project with the total investment because the rate of return will never be the same for every year. Therefore, we are multiplying the life of project with total investment. Therefore, annual profit is 1.5 lakhs, total investment 10 lakhs, and the number of years is 10. So we'll get 1.5% as the rate of return on investment. 14th, the closed loop poles of stable second order system could be. So this is the characteristic equation, which is tau square s square plus 2 zeta tau s plus 1. So when we find out the roots of this equation, it will be s is equals to minus zeta minus under root zeta square minus 1 by tau. So for system to be stable, we would require both real and negative roots. Therefore, option C is correct. 15th, a first order system with unity gain and time constant tau is subjected to sinusoidal input having frequency omega equals 1 by tau. We need to find out the amplitude ratio for the system. So we know that transfer function for first order system is 1 by tau s plus 1, and amplitude ratio for first order system will be 1 upon under root tau omega whole square plus 1. We know the value of omega, just substitute the value of omega here and we'll get amplitude ratio as 1 by root 2. Next, sphericity. So sphericity is the ratio of surface area of sphere to the actual surface area of the particle, and mathematically it can be represented as 6 by dp sp by vp, where dp is the diameter of particle, sp is surface area of particle, and vp is volume of particle. And on rearrangement we'll get this particular form. Therefore option A is correct. Next, we have to arrange these equipments in the decreasing order of average particle size produced by each of them. So option A is correct, which is jaw crusher, ball mill, and then fluid energy mill. Fluid energy mill will produce the smallest particles. Moving on to the next question. Choose one that is not an exothermic process. So catalytic cracking is not an exothermic process, which is option B. Next, the commonly used solvent in supercritical extraction is, the correct answer is carbon dioxide, which is option D. 20th question. The average boiling point of aviation turbine fuel is closest to that of, the correct option is D, kerosene. Next, the number of degrees of freedom for an azeotropic mixture of ethanol and water in vapor liquid equilibrium is, so we know that F is equals to 2 minus pi, pi is number of phases, N is number of components, R is the number of reacting species, S is the special constraint. Since we know that this mixture is azeotropic and hence it's a special constraint, therefore it is S is equals to 1. Number of phases 2, paper and liquid both are there, and number of components is also 2. So the degrees of freedom would be 1. Next, the partial molar enthalpy of a component in an ideal binary gas mixture of composition Z at a temperature T and pressure P is a function only of. So partial molar enthalpy is a function only of temperature. For this, we can refer to Gibbs theorem, which states that partial molar properties in an ideal gas mixture will behave as the molar properties of pure ideal gas. Therefore, the enthalpy would be function of temperature only. Next, which of the following identities can be most easily used to verify steam table for superheated steam? So, for this, del V by del T at constant pressure is equals to minus del S by del P at constant temperature, which is option D. Next, the dimensionless group in mass transfer that is equivalent to Prandtl number in heat transfer is Schmidt number. The Reynolds analogy for momentum, heat, and mass transfer is best applicable for. So when it's Reynolds analogy, the Prandtl number and Schmidt number will be close to 1. So which is true in case of gases. Therefore, correct option is gases in turbulent flow.
That was end of section 1. Now we'll be moving towards section 2. You might have noticed that few of the questions were really memory based. It's like if you remember them, you'll be able to do it. So that is why I say it's very important to read books. Now without wasting any time, let's move to section 2.
The coefficient of x square in the Taylor series of cos square x is, so we know that Taylor series of cos square x is 1 minus x square plus 1 by 3x to the power 4 minus 2 by 45 x to the power 6 and so on. So we can see that coefficient of x square is minus 1, which is option D. Next, three grades of paint A, B and C. The production rates are given and the number of off-spec batches in a day is 1, 3 and 2 for grades A, B and C respectively. We have to find out the probability of picking an off-spec batch from randomly chosen area. So the production rate is 2 batches per day for A, 24 batches per day for B and 18 batches per day for C. Off-spec batch for A is 1 and for B is 3 and C is 2. So out of these three batches, the probability of choosing one batch is 1 by 3 and probability of choosing off-spec batch is for A is 1 by 3 into 1 by 2, for B is 1 by 3 into 3 by 24 plus for C is 2 by 18 into 1 by 3. So what I am getting is 53 by 216 and there is no such option given here. If you know any better methodology to do this question, you're most welcome. And yeah, but I feel the methodology is correct and the answer is also correct here. So in this question we have to find out the drag coefficient, and for finding out the drag coefficient, first of all we need to know the Reynolds number. So we have kinematic viscosity, which is dynamic viscosity upon density. So we know all these values, and on substituting that we'll get Reynolds number is equals to 10 to the power minus 3. So for this range the coefficient drag formula is 24 upon Reynolds number. So the correct answer is 24,000, which is option A. 29th, a gas having density and viscosity, okay, is flowing through packed bed at a superficial velocity of 2 meter per second. And the pressure drop is also given. We have to find out the pressure drop of another gas with density and viscosity values and flowing at 3 meter per second. So for this, first of all, we need to know the Reynolds number of the particle for both the gases. So the value is 1500 for both of them, and if the Reynolds number of the particle is greater than 1000, Burke-Plummer equation should be used. And from this equation we can observe that pressure loss is directly proportional to the velocity square. So pressure drop, taking the ratio of both the pressure drops, we'll get delta P by L of first gas upon delta P by L of second gas is equals to velocity of first by velocity of second. All we need to do is substitute the values and we'll get the pressure drop for another gas as 18,900 pascals per meter. 30th, a pulse tracer is introduced in an ideal CSTR at time is equals to 0. We have to find out the time taken for exit concentration of the tracer to reach half of its initial value. So CA is CA naught by 2, which is half of the initial value, and we know that CA is given as C naught e to the power minus t by tau, and we have to find out this time. So on doing basic mathematical calculations, we'll get T is equals to 0.693 times tau. Next, a batch adiabatic reactor at an initial temperature of 373 Kelvin is being used for the reaction A goes to B. So the heat of the reaction is minus 1 kilojoules per mole. Heat capacities of A and B is 50 joules per mole Kelvin, and we have to find out the temperature rise after conversion of 0.5. So we know that energy balance equation is given by this, and conversion is given CPA, that is heat capacity of A and B is 50 joules per mole Kelvin, and heat of the reaction is minus 1 kilojoules per mole, and converting it to joules we'll get minus 10 to the power 3 joules per mole. So on substituting these values we'll get this, and NT by NTCP, which is total number of moles into total heat capacity, we'll get Na, which is number of moles of A, into heat capacity of A plus number of moles of B into heat capacity of B. So we know that Na is Na naught 1 minus Xa, and Nb can be written as Na naught Xa. On substituting the value of Cp A, Cp B and conversion, we'll get 50 Na naught. All you need to do is put this value here, and temperature rise would be 10 degrees Celsius. Next, steam undergoes isentropic expansion in a turbine from 5000 kilopascal and 400 degrees Celsius to 150 kilopascal. We need to find out the exit condition of steam. Since it's isentropic process, we know that entropy in would be equal to entropy out. So we know the value of entropy in. Entropy out would be entropy of liquid plus quality of steam, which is X, multiplied by entropy of vapor minus entropy of liquid. So we know the values, substitute them, and you will get X is equals to 0.9. Therefore, the correct option is partially condensed vapor with quality of 0.9. Next question. According to Fenske equation, what would be the minimum number of plates required in distillation column to separate equimolar binary mixture of component A and B? Okay, so we know the distillate composition, we know the bottom composition, and we know the relative volatility also. So this is the Fenske equation, where Nm is the minimum number of plates. Xt is distillate mole fraction, Xw is bottom mole fraction, and alpha is relative volatility. Substitute all the values and you will get Nm as 12, which is the minimum number of plates. 34. A 10 cm dia steam pipe carrying steam at 180 degrees Celsius is covered with an insulation having conductivity 0.6. It loses heat to the surrounding at 30 degrees Celsius. Heat transfer coefficient is given. This is 0.8. There's a small typing error here. And if we neglect the resistance of the wall and film resistance of steam, the rate of heat loss from insulated pipe will be, so we need to tell if it is greater than uninsulated pipe or less than uninsulated pipe. So the rate of heat loss from insulated pipe is given by this relation. We know the value of x, 2 centimeter. We have just converted it into meters. And Q1 by A is 116.8. And similarly, if we find out for uninsulated pipe, the rate of heat loss is 120. So rate of heat loss from insulated pipe is less than that of uninsulated pipe. Next, 1000 kg of liquid at 30 degrees Celsius in a well-stirred vessel has to be heated to 120 degrees Celsius using immersed coils carrying condensing steam at 150 degrees Celsius. So area is given, heat transfer coefficient is given, heat capacity is also given. We need to find out the time taken for the liquid to reach desired temperature. So it's a problem of unsteady state heat transfer. So this is the formula to be used. So Tf is the final temperature, Ti is initial temperature, and T infinite would be the temperature of steam. So here you can see I have written it I've written HA term in the denominator and MCP in the numerator, which is wrong. The third line is correctly represented. So the time is 51.34 minutes. All you need to do is just substitute the values and find out the time. Next, fresh orange juice contains 12% solids and rest water. 90% of the fresh juice is sent to an evaporator to remove water and subsequently mixed with remaining 10% of the fresh juice. We need to find out the kg of water removed from 1 kg fresh juice. Okay, so for these kind of questions, it is better to represent them like this, and we'll do overall solid balance on the basis of 100 kg of feed. So we will get P, the product is 30 kgs. And if we do the overall mass balance, which is F, feed, water is represented as W, and P is the product. So W is 70 kgs. And when we want to find out the amount of water removed for 1 kg of fresh juice, it's W by F, which is 70 by 100. 0.7 is the correct answer. So the solubilities are given at 60 degrees Celsius and 25 degrees Celsius. We have to find out the amount of crystals which are formed during this process. So the solubility at 60 degrees Celsius can be found out by this, and similarly for 25 degrees Celsius. So the crystal formed would be 0.375 minus 0.167, that is the difference of solubilities at both the temperatures, which is 0.2 kgs. In hydrodealkylation of toluene to benzene, the following reactions occur. Toluene to hydrogen ratio is 1:5. 80% of the toluene gets converted, and the selectivity of benzene is 90%. So we have to find out the fractional conversion of hydrogen. So fractional conversion of hydrogen is the hydrogen consumed upon moles of hydrogen at the inlet. So toluene in the feed is 1 mole. It is already given. Toluene out would be 1 minus whatever the toluene is converted, which is zero point 0.8, and we'll be left with 0.2 moles of toluene. We know that selectivity of benzene is moles of benzene formed upon moles of toluene converted. We can easily tell the moles of benzene formed, which is 0.72 moles. So fractional conversion for benzene from reaction scheme 1 and 2 can be written as this. And similarly for toluene, it can be written as 1 minus fractional conversion for 1 is equals to 0.2. This is for toluene. So from here we'll get it as 0.8 moles. And if we substitute 4 in equation 3, we'll get fractional conversion for 2 is 0.04 moles. So moles of hydrogen formed would be whatever the moles of hydrogen at the inlet minus the moles of hydrogen used in the reaction. So, or hydrogen formed in the reaction. So it is 5 minus 0.8 plus 0.04, which is 4.24 moles of hydrogen were formed in the reaction. So fractional conversion of hydrogen is equals to moles of hydrogen at the inlet, which is 5 moles, moles of hydrogen out, which is 4.24, upon moles of hydrogen at the inlet, which is 5. So the correct answer is 0.152, which is option C. Here we have to tell the net present value of annuity at an interest rate of I. So it's just a formula. If you remember this, you will be able to do the question. So the correct option is B. This question is a bit lengthy. So a company has a depreciable investment of rupees 36,300, which is depreciated in equal installments in 2 years. So we have to assume that tax rate is 50% and interest rate is 10%. So the net present value of tax that the company would have saved if it had depreciated two-thirds of the investment in first year and rest in the second year. So I have done this question in two parts. When the company has depreciated in equal installments, and case 2 when the depreciation is 2/3 of the investment in first year and 1/3 in the second year. So we know that total money invested is 36,300. The depreciation after 1 year is 18,150, and the amount of tax would have been saved if the depreciation had not occurred is 9075 0.5 because the tax rate is 50%, and present value after 1 year is 8250. Similarly, for the second year it is 7500. So the total present value of tax which has been saved is rupees 15,750. We have just added the present value after 1 year and the present value of the second year. So case 2 would be when the depreciation was 2/3 of the investment in first year and 1/3 in the second year. So depreciation after 1 year is 24,200, and the tax saved at that year would be 12,100. So the present value after 1 year would be 11,000. Similarly, for depreciation after the 2 year, it is 36,300 multiplied by 1 by 3, which is 12,100. Similarly, the amount of tax which the company would have saved is 6,050, 0.5 because the 50% tax, and present value after 2 years would be 5,000. So the total present value of tax is the amount after 1 year and the amount after second year, which is 11,000 and 5,000. So the total amounts it to 16,000, and the saving on net present value of tax is 16,000, which is the case 2, minus for the case 1 it is 15,750, and if we subtract them we'll find out the saving, which is 250 rupees. Next, the frequency response of first order system has a phase shift with lower and upper bounds given by. So phase shift is tan inverse minus omega tau. So the lower bound would be when omega is equals to 0, and when we put omega is equals to 0 and phi equals tan inverse omega tau, we'll get the lower bound as 0, and upper bound when omega is equals to infinite, which is pi is equals to minus pi by 2. So the correct option is C, minus pi by 2 to 0. A cylindrical pressure vessel of volume 6 pi meter cube has to be designed to withstand maximum internal pressure of 10 atmosphere. We have to find the thickness of the vessel, allowable design stress is given, and the corrosion allowance is 2 mm, and L by D ratio is 3. So we know that volume of vessel is 6 pi, and the vessel is in the form of cylindrical shape. Therefore pi d square by 4 into L is equals to 6 pi. And in place of this L we can write it as 3d from equation number 2, and on doing that we'll get d as 2 meters. So if we know the value of d, we can easily find out the value of L, which is 6 meters, and thickness of the vessel is given by this relation. P is the pressure, D is diameter, and sigma, which is allowable design stress. So we are converting it to all the SI units, and on doing that we'll get thickness of the vessel as 0.01 meters, which is 10 mm. Next, a composite wall consists of two plates A and B. The thermal conductivities are given and heat capacities are also given. So plate B has twice the thickness of plate A. At steady state, the temperature difference across A is greater than the temperature difference across B. When? So we have to find out that particular condition. We know that heat flow across A is equals to the heat flow across B. So according to the Fourier's law of conduction, we can write this, and x and x will get cancelled, and we are writing 2x here because the thickness of B is twice the thickness of A, therefore 2x. And it is given that delta TA is greater than delta TB. If we take this to the RHS, we'll get delta TB by delta TA less than 1. And from the first line, which is Ka by x delta Ta is equals to Kb delta Tb by 2x. From here you can see that delta Tb by delta Ta is equals to 2 times thermal conductivity of A upon thermal conductivity of B. So all we did was substitute it here, and yeah, the correct relation is C. So it takes 6 hours to dry a wet solid from 50% moisture content to the critical moisture content of 15%. How much longer will it take to dry the solid to 10% moisture content under same drying conditions? We know that drying curve consists of constant rate period and falling rate period. So we can make use of both the relations of constant rate period and falling rate period. We can find out this term, which is Ls by A into Rc, which is the rate term, from constant rate period, which is coming out to be 17.14 hours. And on substituting this in the falling rate period equation, we will get the time as 1.18 hours, which is equivalent to 71 minutes. Option C is correct. Next, what is the critical rotation speed in revolutions per second for ball mill of 1.2 meter in dia charged with 70 mm dia balls? Okay, so for critical rotational speed, we have this formula, which is 1 by 2 pi under root g, where g is the acceleration due to gravity. Capital R is the radius of ball mill and small r is the radius of balls which will be used. So the diameter of balls is in mm, we'll convert it to meters, and the correct answer is 0.663, which is option D. So a sand mixture was screened through standard 10 mesh screen. The mass fraction of oversized material and feed, overflow and underflow are given. So we have to find out the screen effectiveness based on the oversize. So we know that feed is equals to W plus Z, which is overflow material plus the underflow material. Basic mass balance we are doing here. So on doing that, we will get Z by F is equals to 16 by 57. So screen effectiveness based on oversize is 0.79, which is overflow mass fraction, upon 0.38, which is the mass fraction of feed, into Z by F, both the quantities. So the screen effectiveness is 0.583, which is option B. Next, a rigid vessel containing 3 moles of nitrogen gas at 30 degrees Celsius is heated to 250 degrees Celsius. Assume average heat capacities of nitrogen to be, okay, it is given, and heat required, neglecting the heat capacity of the vessel. So we have to find out the heat required, which is N into CV into T2 minus T1. All the values are given, just substitute them and we'll get Q is equals to 13728 joules. Next, 1 meter cube of ideal gas at 500 Kelvin and 1000 kilopascal expands reversibly to 5 times its initial volume in an insulated container. We have to find out the final temperature. So the relation between volume and temperature is T2 by T1 is equals to V1 by V2 to the power gamma minus 1. So we know only the specific heat capacity at constant pressure, which is Cp, and gamma is equals to Cp by Cv, and Cv is Cp minus R because of this relation, and gamma would be 1.655. So we'll substitute the value of gamma in this equation, which is equation number 2. So T2 would be 174.24 Kelvin. In the manufacture of sulfuric acid from elemental sulfur, the following sequence of major operations. Okay, which one is correct? We have to find out. So in the manufacturing of sulfuric acid, the correct sequence is furnace, then converter, and then absorber. which is option A. Next, we have to tell the catalyst used for steam reforming of methane and ammonia synthesis. So for steam reforming of methane, catalyst is nickel and aluminum oxide. And for ammonia synthesis, catalyst is iron and aluminum oxide.
So it's time to say goodbye now. Don't forget to tell me about the subjective questions. I'll make another part of this video, and we have much more interesting stuff on our channel. Do have a look, and last but not the least, don't forget to like, share and subscribe.